Welcome to our third quarter threat research roundup. We're providing you with insights into the latest malicious campaigns found here at Reversing Labs. My name is Paul Roberts. I'm the Director of Editorial and Content here at Reversing Labs. I write a lot of the blogs and do webinars and podcasts and stuff like that. Longtime cybersecurity reporter. And with us here in the studio, we have two of our outstanding threat researchers. So I'll get to introducing them in a second. Before we do that, who is Reversing Labs? If you don't know, we are a 15-year-old company. We actually just celebrated our 15th anniversary, both in Zagreb and here in Boston. It was a lot of fun. And we have basically the world's largest searchable threat repository of malware, 40 billion files of badware, goodware, grayware, 8 times larger than our nearest competitor. And we are used by a wide range of cybersecurity companies, as well as other infrastructure companies, financial services companies. We're behind a lot of the security tools that you may rely on. They come to us for information on malicious or suspicious files that they encounter. We're scanning around 20 million of files daily. And recently, we have gotten into, really dug into the software supply chain risk problem and identifying threats that may lurk in compiled binaries. And that is just an outgrowth of our expertise in threat analysis, file reverse analysis, and so on. And Gartner has recognized us as a software supply chain security solution, and CRN recognized us for our partner program. We contributed data last year and plan to do so this year to the Verizon's Data Breach Investigations Report. So we're a really good source of information on file-based threats, supply chain-based threats. And that's what we're going to be talking about today. Let me go ahead and introduce our two speakers, Carlo Zanchi, who is a reverse engineer and threat researcher here at Reversing Labs, and Lucia Valentic, who is a threat researcher. We've talked numerous times before. They do amazing work. Carlo and Lucia, you want to say hi to the audience?
Hi.
Hello.
Thanks so much for joining us. And I guess to start off, has it been a busy quarter for you all? Is the work picking up steam or trailing off? How has Q3 been generally compared to other quarters?
Well, each quarter is busy at us, and the latest one, especially since in June, Spectre Sure for Community was published, so our work became public and visible in live time. So it's become a bit more crowded than usual, at least from our side. We need to be on watch, be faster and more responsive to threats.
So we'll talk about that. That's a secure.software site, and you're getting contributions from developers there as well, right?
Yes.
Yeah. We'll talk about that near the end. Okay. So what we're going to talk about today, in terms of the research that we've reported, we did our last threat research roundup like in July, so we were actually kind of into Q3, and some of the research that we published in Q3 we talked about then just because it was fresh off the press. But we're going to talk about first of all the most recent research we did, continuation of this campaign called VMConnect, that is a North Korean state-sponsored campaign, largely targeting developers. Also a further noise iterations around the IM reboot campaign. This is a NuGet campaign dating back to 2023. And then some smaller stuff that we kind of tweeted about, X'd about, and shared just discoveries that that we thought development community should know about open source threats. So that's going to be our discussion, and we'll talk a little bit at the end about obviously, as Carlo mentioned, the secure.software site and how developers can kind of make use of some of our intelligence. Okay. Let's start off with the most recent research that we publicized. This was a piece that came out, a research that published about a few weeks ago, um, regarding some malicious Python packages that we found targeting developers as part of a basically fake job recruiting scheme. Um, Carlo, if you could, this research you did it. If you could tell us just a little bit about like how this first got on our radar here at Reversing Labs.
Yeah, well, the entire campaign was started in summer 2023.
Yeah.
And at that moment, we wrote two blogs, research blogs about that topic. We found the malware in Python packages, and we related it to some malware described in one of Japanese threat research blogs, and they
Yeah.
provide some threat hunting URL rules, which we continuously monitor from our side. And this summer, new matches of the same malicious samples appeared on that threat hunting URL rule, and we noticed that most of the packages were part of most of the samples were part of zip archives, so like packaged repositories from GitHub, and they were all related to um, financial institutions, and that's how we came to conclusion that this is something interesting and a new part of that old campaign. So basically, we have a threat monitoring YARA rule, which we monitor in our spectral detect solution, and new samples came up uh, on
And
that.
that was And I think you said, I think Japan CERT was the one who initially created that YARA rule. So
Yes.
that goes back quite a while. And basically we just saw new packages that triggered that YARA rule. Um, and so you guys dug into those packages a little bit and tell us what you found when you looked inside these, zip archives and what popped out at you.
Well, those were all test solutions for job interviewers. So people searching jobs were provided with these home tasks to solve, fix what need to be fixed, and show the results to the recruiter. What was interesting, they were given a link to a GitHub project, and
Right.
developers could clone that repository, fix what they needed to do, and submit the fixes. One of the malicious containers we found had Git artifacts, which led us to helped us find concrete persons who got compromised during these incidents. And basically, what they told us, yeah, uh, they were approached by a fake job recruiter, given the home
Yep.
task, and asked to make screenshots of the fixed solutions. So in order to make them run the malicious solution. So that was their entire goal. And if you wanted to show screenshots, you need to start program malicious package program on your computer. And
Right.
that's how and additionally, they made a sense of hurriedness, giving a small time frame to do the required tasks.
Right. So there's a screenshot here that was taken from the blog post where it basically is showing this coding test, which was a password manager.
Yes.
And you can see the instructions for the job candidate before making any modification. Basically make sure you've installed and are running the file. So that was basically their way of saying, even if this person doesn't complete the exam, the test, we'll make sure that we push the
Yes.
malware on it. Yeah. And And what do we know about the malware in question here? Was this different from the earlier iterations of this VMConnect campaign that we'd
No,
seen? Same malware or what?
this is basically the same downloader component of the malware that has been seen in the campaign from the last year. The final
Right,
payload can be different, but it's basically the same malware, the same downloader, like already described in so many blogs related to North Korean threat actors in last, I would
right.
say, 2 months. Most of the blog pieces were describing malware related to NPM package repository. In this case, we had Python-related malware targeting Python developers. So this threat actor is all across different developer ecosystems and targeting everybody they can get on, and they are quite sophisticated at it. They are having victims falling for their fake recruiter job scheme. They're creating fake LinkedIn profiles, contacting people over those, and here and there somebody pops in and they steal their data. This is the same approach they've been using for a long time. The main target of this threat actor is cryptocurrencies, and their goal is to get financial gain for their needs, whichever they are, and they are mainly focusing on cryptocurrency software, but also like in case of 3.6 supply chain attack, where the company was compromised over cascading supply chain attack. The initial vector was the compromised X-Trader application. So again, a cryptocurrency related application.
And what is the so in this case, what is the connection between the developers and so these are info stealers that they're putting on the developer system
Well,
and what
downloaders, they're downloading second stage
yeah,
are stealers of various
right, right.
types. Yeah.
Do we know the connection to the crypto angle or is that we don't have the information to connect the dots there.
Well, some of the previous malware were abusing, impersonating crypto-related
Right,
packages on NPM
right,
pipeline, similar stuff.
right. Now, one of the really interesting things in this campaign is we actually got some really, because we were looking at these test coding assignments, and there was a lot of details in those, and identifying information, and some of them about the developers who had downloaded and taken these tests. We were actually able to get some insights into the shape of this campaign, and generally ReversingLabs, like, we're not an endpoint detection, vendor. We're looking at the malware specifically. We don't necessarily have a view of the whole campaign. But in this case we did, and we have a screenshot here, again, taken from our blog post, that is the kind of assignment. And one of the things that's really interesting here, first of all, it gives you a sense of the sort of time pressure that these folks were under, which is, of course, going to make them less likely to dig into the code that they're downloading and say, well, hold on, right? So, you got 5 minutes to build the project and you got 15 minutes to fix it and get it back to me. That's going to preclude you from actually being like, well, let me make sure it's not malicious first.
Yeah, that's the old
Right.
story when they try to fake you. You have 50 minutes to use this bonus, this discount or something like that, just variation.
Right.
Yeah.
The other thing that's interesting here, if you look, welcome to Capital One technical interview. So Capital One, major financial services firm. Obviously, this isn't an actual Capital One project or file or campaign, but it gives us some insight into what the campaign was, who was being impersonated here, which is a financial services firm. And Carlo, if I'm not wrong, there were other examples we saw
Yeah, I think that was one.
impersonating other financial services firms.
Yeah, impersonation. That's not related to those institutions in any
Companies,
way,
yeah.
but they are presenting like they are from those institutions, recruiters. So
Right. For a developer, obviously, working for a financial services firm is going to be attractive, a good gig. We don't know if they were targeting developers who are working for other financial services firms or organizations. That's certainly a possibility, I guess.
Yeah, we can't say that for sure, but they are definitely that's something that can point us to what type of developers they were looking for with someone who had experience. Probably they weren't targeting a full total junior. They are looking for someone who had experience with that type of applications.
Okay, so if you're a developer or a manager of other developers in an organization, obviously this is something that you're definitely going to be worried about as a threat vector. Where should they have looked to determine whether this was a benign open source project or whether there was something suspicious about it? Where were the telltale signs
Well, you
for this?
always, when you get something of the type, hurry up, hurry up, hurry up. As I said,
Yeah,
that's an old scheme. You need to hold that, stop for a moment, and ask you why is someone making you hurry. That's not something that should be done by anyone, not especially not by job recruiters. So take a
yeah.
moment, think about it. That's already suspicious. Whenever
And for this,
someone
where were the red flags in this particular package?
Yeah, well, you need to look a bit more details, but those were implementations of PyTorch and Paperclip modules, which contained some unusually long base64 encoded strings, which were then decoded and executed. So if you see a large base64 blob inside your package and it is not private certificate or something like that that you should expect, then you should take a detailed look of the content of that base64 encoded string that was
Right. Okay.
visible for play.
So we have a question from one of our viewers. You mentioned that the attackers are asking to execute the Python file. Are there Python files hosted in any open source Git repositories? Let's see.
So
Are there any Python files?
these
Yeah.
these projects were hosted on GitHub uh, repository. Anybody
Yeah.
could take them. I even believe that those weren't private project. There were some cases when developers were given a link to private GitHub, access to private GitHub project. But in this case, I think this was a public GitHub project that anyone could download. We even found later, we will talk about that, but the day we contacted the victim, another publicly available GitHub project containing the same malware was published to GitHub repository. So
Hmm.
this was from a public GitHub repo.
Right. So the platform itself is not necessarily scanning for this type of thing. It really is falling to folks
Well,
like,
you
yeah,
have a lot of malicious content on GitHub,
yeah,
and we constantly uh, get to find mm, PyPy projects and all other types of open suspect repositories taking second stage malware from GitHub hosted files. So that's a common practice. I can give you from hand, we report those repositories, but attackers open new ones,
new
and
ones,
when they
right?
get removed,
Right.
there's a lot of malware on GitHub.
They're huge platforms. There's a lot of
Yes.
activity on a daily basis. Very difficult to monitor for malicious
Some
activity.
of the pipe packages we came across publish malware on GitHub, and the same day they remove it. The other day they put new version up, and they again remove it. So you only see it in commits. The latest
Right.
state of the repository is clean. So,
So one of the things I found was interesting, if you look at the earlier iterations or versions of this VMConnect attack, they were more they were a little less, as we would say, hands-on. So they were really sort of mimicking popular packages and basically kind of trying to trick developers into downloading and installing them. This one seems a little bit more like you know, like there are
engaged.
humans at keyboards on the other side of this attack, right? They're not just kind of throwing stuff out there and hoping to catch a developer. So a little bit more effort and resources put into this. Yeah.
Well, these are North Korean linked threat
Yeah.
actors, and they have a lot of resources at their disposal, from human resources all the way to technical knowledge, and they are present across all different. They're using all kinds of infection vectors for their needs, because they are
Yeah.
really, really one of the most active threat actors in open source package repositories and simple web.
Yeah. Clearly very focused on developer supply chain.
Yes.
You know, one of the other things we've seen, this wasn't related to this campaign, but I think the company KnowBe4 disclosed that they had accidentally hired a North Korean threat actor, thinking that they were based in North America. And then that person immediately tried to sort of push malware onto their network, and they shut it all down and dug into it. But you know, again, this seems like a very kind of hands-on campaign to infiltrate development organizations, either using software or in this case, using a human being to, you know, get access to sensitive platforms, sensitive environments, sensitive data.
Yes, they are
And
very
again, yeah,
creative threat actor and using all
yeah,
kinds of
yeah,
approaches. So
yeah. So
yeah,
be
very
careful out
active.
there. Be
Yeah.
careful, especially if you're hiring. All right. Moving on. Moving on. And again, if you got questions, use the Q&A feature. We're taking your questions, and you got Lucy and Carlo here, two experts. So, you know, don't pass up that opportunity. Okay. Um, the other major campaign that we wrote about this quarter was a continuation of a campaign that we've written about in the past. We dubbed it "I Am Reboot" in its earlier instances, and it is a campaign leveraging the NuGet platform. And this was one, again, we talked about it in our July threat roundup, but we've seen some continued activity here with this campaign. New packages and so on. So, Carlo, for folks who may not have been on our July threat roundup, could you just give us a quick overview of the I Am Reboot campaign, and also what we found back in June?
Yeah, well, the entire campaign is active since August 2023, again, last summer. The threat actor, this is interesting campaign because threat actors are continuously improving their approach. They are using some, I would say, advanced technical solutions to plant malware. It's not, they started with simple malware downloader malware in initialization scripts like init.ps1 and simple stuff that you see across NuGet packages. After that, they moved a bit further and added malware to MS build tasks, which were powered during the installation and compilation of modules, NuGet modules through Visual Studio. So that's one step further, which we don't usually see malware abusing that. And then finally, around the end of the year, they adopted a technique called ill weaving, and they were been using it ever since, which involves patching compiled.NET libraries with module initializer containing malicious code. Basically, what they do, they take a fully functional NuGet DLL from one NuGet module. They patch it with ill weaving, add some code to it, so compile some code into it, keeping all of its initial functionality, but putting some module initializer code which gets triggered before the entire module gets loaded. And then they package it into a new NuGet package which tries to impersonate the original package. We had, I don't know, PayPal impersonation and few other popular packages being impersonated, actually containing fully functional PayPal package from their NuGet package
Mhm.
and adding this malicious functionality. So they've
Interesting.
also been abusing homoglyph characters to bypass NuGet's reserved prefix security feature they have. They're very clever and creative also, and using cutting edge features to put. I, Perhaps cutting edge is not the greatest expression, but edge technologies and features of NuGet
Right.
modules.
Homoglyphs are just characters from different languages that are identical to
Look,
Latin.
visually look the
Yeah.
same. Yeah.
Yes, but logically, their actual value is different, and so you can
Yes.
fool the developer, but have a distinct package on the platform itself. Lucia, I'd ask you, NuGet is not been historically a common platform for threats. We think more in terms of like NPM and Python, package index, PyPy. Are we seeing more activity around platforms like NuGet?
Well, here and there, but I think NuGet is still not as active as is NPM and PyPy. Those are the most active. We have seen activities on NuGet on VS Code Marketplace, but it's still not as close to as it is on NPM. There has been weeks where we haven't found anything on NuGet, and then some interesting malicious packages get published. So of course we've done research about that. Mostly Peter is doing research and sometimes Carlo also.
Do we think that's just because of the developer population, that malicious actors, they want to be on the platform where you've got the biggest audience of developers, or are there things about NuGet as a platform that complicate malicious campaigns?
Well, probably they are looking at where the most developers are, but also every few months, how many malicious packages on each repository are exchanging. For example, last year NPM was very busy, and this year I think PyPy is more busy than NPM. So it's always changing, probably depending on which repository malicious actors want to deploy malicious software on.
Right. So, one of the things that you all discovered were again new packages in around the August timeframe. And what can we tell viewers just about the latest packages? I think it was one called Libin Better. Is that correct?
Yeah, we detected that package, and around the same time we came across one Reddit post where someone complained about being affected after downloading
Yeah.
some NuGet module. They weren't sure which one was it. They just mentioned what they were searching for, and when they typed the module they wanted to find, I think that was something related to phony, not exactly embedder, but since one of the top 3 solutions was the malicious package. So why that happened is because the threat actor is constantly pumping up download numbers for NuGet packages, and they publish like 20 versions of the same package in the same day. Early versions containing no functionality or only the legitimate functionality, and they automatically pump up the download count by using some automated platform they created. And in the end, they put 1 or 2 malicious versions containing malicious functionality, which don't really have too many downloads. And when you search for a package, you accumulate, I don't know, 20 versions, each having 100 downloads, and you quickly rank up to the top of relevant packages in NuGet search system. So that's how the person got infected. And obviously, here and there it works. So
And we've seen this strategy before. Lucia, I think you wrote about this as well. This kind of strategy of, posting non-malicious packages, letting them either kind of sit there or doing kind of frequent, updates, and then at some point it switches to having malicious content in it, and you've already got a user base that you can immediately infect.
Yes, there was this one package on NPM that was legitimate, but it was published 2 years ago last time. So malicious actors were trying to mimic that package, and they're trying to pass their packages legitimate one as continuation of the legitimate package, just a new version. And they were publishing that package for like 2 months. The package was legitimate, it was clean and everything. And after 2 months, they published another version that was malicious, that was, I think, downloader. So probably they were trying to build community on already existing one. And they're trying to pass their package as malicious one, as legitimate, and then they switched on their community and obviously trying to infect others. And we have seen this kind of things happen a couple of times since then, actually.
And are these like typo? I mean, is this like just fooling them, like typo squatting, like just kind of playing on developers being distracted and not noticing a slight name difference, or are they trying to pull in developers based on the functionality of the package?
They're trying to pull, sometimes they're trying to pull developers based on functionality, and sometimes they're not fully using typo squatting, but they're using the name of a legitimate package, and they are transforming in a way they're like putting legacy plus the name of legitimate package or something. So those malicious packages as continuation to another packages. So they're not using fully typo squatting, but they're still using the names of legitimate packages.
Right. And this libembeddor package, was this commonly used? Is it a play on a commonly used package, or what is the draw here for this?
Yeah, well, like I said, phony is a tool for performing ill-weaving or patching of compiled executable, and they are libembeddor is, yeah, well, you are embedding something into library, so, and they have
Right.
phony suffix, so it's basically representing itself as a tool for patching binaries, which it
Right.
actually does, but in malicious way.
And here we've got a screenshot from Spectra, from the Spectra platform, showing, first of all, 4 supply chain attack artifacts and a failing the security scan with a designation of malware. So that's good. Good to see. Good to know that. Carla, can you just sort of give us a sense of what triggered that within Spectra when we scan this package?
Yeah, we have a combination here down at the end. You can see the behaviors, execution behavior, which says that it contains module initializer, the method we mentioned earlier. So basically, that's one of the behavior indicators we are looking at the bottom of screen. And the other combination were the usage of obfuscation, not so commonly seen in open source package repositories. So there are different flags. In this case, we were hunting for module initializer, and that's not exclusively malicious functionality, but in combination with some other suspicious behavior, you can it can lead to a malicious package, especially since this campaign has been continuously abusing this feature.
Yeah. And this is kind of the capability that organizations need, right? Increasingly, which is the ability to kind of see these, what amount to subtle, distinctions or differences in packages that might not jump out at you as a developer, downloading and scanning the code, but that associate, when you look at the broad landscape that we're capable of, that correlate with malicious activity, right?
I believe there is still large number of developers who simply seek for a dependency that fulfills their needed functionality and then doesn't check for security concerns. I won't
Right.
say that everybody is doing it in that way because they are not aware of threats lurking there outside, but a very small number of developers have access to tools which can help them at assuring if some dependency is malicious or not. And
Right.
the awareness is still not, I would not even say probably not even 3/4, not even 75%, but from those more than half that perhaps are in my pink glasses are are aware that there are threats. I believe that a small number of them are performing security vetting because either they don't have knowledge, either they don't know the tools they can use to help them perform security assessments.
Right. And these are the types of analyses that you really need tools to do. You're not going to be able to
Yeah,
just,
most of
do
people
it.
want,
Yeah.
especially at NuGet, where you have
Yeah.
compiled packages in
Right.
PyPy and NPM, that is JavaScript, Python. You can look at the code. Again, if you have 50 Python files in a package, you likely won't have time to look at all of them. So you again need tools, but at NuGet packages, you
You
need
can't
to
even
know
look at the code.
reversing
Right.
to
Right.
be able to detect something in that.
So we have a question from the audience. This is from Lazaro. I'm currently 9 months into my first cyber role working as a DFIR analyst. Would it be a good idea to do some type of threat research or intel to see what threats can affect our environment? Thank you.
Yeah, if we're talking about developer environment, the organization needs to be aware that it's not only downloading some content from internet that is infection vector for their community. Let's say you have Visual Studio Code. Lots of people program in Visual Studio Code today. You have extensions, which are just modules for Visual Studio Code. Each of those extensions contains executable code. So each of your development tools can be bypassing your security measures. So you need to, if you're a development organization, you need to have, let's say, a list of development tools that are acceptable inside your organization. You need to know what your developers are using. The first thing is to, let's say, like on the firewall, forbid everything and then make exclusions what can be used. And when you know what tools are being used, you need to perform security assessment of the extensions you use for those tools. And again, libraries from open source you are going to use in your packages. You can't just give developers, okay, go find functionality what you need and add it to code base. You need to handle the risks. You need to perform security assessments of the third-party software you include into your software, not only because your environment can get infected, but because you ship your software to your clients and they can get affected. So it's upon organization themselves to make sure they are safe and they ship safe software, not somebody else to make sure they don't execute malicious software.
And we've seen that with 3CX and SolarWinds and others, right? So
And
you're right.
others,
It's not
there
just
are always
right,
somebody failing.
right. And I would say the other thing, obviously, tipping back to our initial discussion around the Python campaign is there's also a developer and employee education component of this too, because it's not simply about what you're doing within the confines of your own development environment, development pipeline. It also is what you may be doing on on your home network, on your personal computer that you then use to remotely access your work environment, right? So malicious actors are going to target your company, and you as a developer at that company, they may also be targeting you individually and get access to your company by way of that. So
There are
right? I mean, that's part
very
of it as well.
there are many infection vectors that you need to take care of.
Yeah.
So lots of
Right.
gates to close and secure.
Right. So here's what you need to do to be secure within our environment, working with our tools. We're doing the assessments of those tools and of the code that we use. And then here's what you need to do to secure yourself outside of this environment, right? To
Yeah.
make sure that you're not a bridge to this environment
Yeah,
for
I'm
another
talking
actor. We've
about
seen some of these
development
here.
environment tools because that's something that
Yeah.
people don't perceive as an infection vector. Everybody knows you can get a malicious email today and you need to watch out on dangerous email. Everybody knows you need to watch on tricky links not to click on. But not so many people have the sense that this is also an infection vector.
Okay. Excellent question. Lazaro, thank you for asking it. Really important point. So those were the two things we wrote full research reports on, but there've been a bunch of other discoveries this quarter that we've had and that we've circulated to the community. One was a package called Beautiful Text. Lucia, could you tell us a little bit more of this? We posted on this back in July, and looks like it took a while for it to actually get pulled down.
Yeah, so as you said, it wasn't a big story. It wasn't a story that we did a full blog on, but it was still, there were some interesting parts of it. So we decided to tweet about it. So Beautiful Text is a package, NPM. It was published in July, and as already mentioned, this kind of package is the one that malicious actor were pushing few versions that were legitimate, that were clean, and everything. And after they built community, and they were trying to build community, they actually published malicious versions. So out of 11 versions of this Beautiful Text package that was up on NPM for 2 months, only 2 versions were malicious. One was downloading just an image, a proof of concept. But the second one was interesting because it was downloading a second stage. Unfortunately, at the time of research, we haven't obtained the second stage because it was down. But we have found malicious payload since it was hidden using base 64 encoding. But it was called once the package was run because it was linked through main script.
Mm-hmm. And this is, so it was Beautiful dash text, and you note that there had been another Python package, Beautiful Text, one word, that we had associated with, that had been associated with, again, North Korean threat actors, again, seeding open source platforms with malicious code. I mean, it would seem they're connected. Do we have any indication of whether these are just part of the same campaign?
Well, they are probably part of the same campaign. We haven't, so Palo Alto, I think 2 weeks ago, published a blog talking about malicious packages on PyPy downloading second stage rat. And one of those packages were Beautiful Text, which of course has very similar name to Beautiful Text. But once we looked at the code, if you can switch to two slides after this one, we can actually observe similarities between Beautiful Text from NPM on the left and Beautiful Text from PyPy on the right. So as you can see, both are sending some string session cookie. They are both downloading second stage, and they're actually checking that they're not running on Windows before downloading. They are both using encryption after second stage was downloaded. Of course, on PyPy, base 64 was used, and on NPM, XOR encryption was used. So that is a bit different. But the link of second stage, it's very similar. The code is not, it's not the same. But the extension and the name of the file is the same. So if you look at basically the type of code and the functionalities and everything, package from NPM and from PIPy are basically the same, so probably they are from the same actor, which Palo Alto attributed to Gleam and Pisces. So probably this one on NPM are also from Gleam and Pisces, which are connected to North Korea.
And so the 9 non-malicious instances of this package, were they functional? And what do they do?
So they were functional, and basically they are trying to change text in console and make it beautiful, which is something that we have seen on NPM before, because malicious actors apparently on NPM like to mimic one legitimate package named colors, which is a legitimate package. It is also making the text in console more beautiful, that it's adding colors. So malicious actors are also using those kind of functionalities to lure developers to their own packages, to their own malicious packages.
So, I mean, that's just something you need to be aware of, right? As a developer, if you're looking for those types of, certain types of packages that have higher risk around them because threat actors are targeting them, right? I mean, it's just sort of, part of your increasing risk awareness when you're out on these platforms to be extra careful when you're downloading a package like that, colors or beautiful text or what have you. If tens of thousands, millions of developers are using it, chances are some malicious actor is going to try and piggyback on that and slip something onto your system. Yeah, interesting. Another malicious package we called out, Cipher Decryptor. Tell us a little, I think, Carlo, can you tell us a little bit about Cipher Decryptor?
Yeah, this is the PyPy story. So last week, I believe there were several packages, I would say combination of packages. Well, basically, it's a technique seen from the first month of this year when we talked about our BIP research. Basically, what attackers do, they implement a malicious functionality which performs stealing of information and exfiltration to some basically not stealing, they are performing exfiltration of the received data to a remote location. So you have a module which receives some data, it has functions, and they send data to remote site. It is usually some innocent looking module performing either base64 encoding, hashcats, I don't know, some niche functionality that is not suspicious. And what's interesting, on its own, that package isn't performing nothing malicious. They are not stealing your data. If you run it, they won't do anything wrong to you. So it's basically a module that's functional. And what they do, they create several packages. Mostly they are related to crypto teams. So BitClip malware was related to crypto team. Soulstructs malware was related to Solana, and these latest are pretending to be wallet decoders, various Phantom wallet decoder, Exodus wallet decoder, and similar packages. What they do, they import the previously malicious, let's say, InfoStealer, the original package, which performs deploying secrets, and they use it as a malicious dependency. So basically, you install yourself an Exodus decoder package, which imports Cipher Decryptor package as a dependency. And what they do, they promote themselves as packages for decoding wallets and retrieving lost wallets. So basically what they ask from you is to use that package to retrieve your wallet. And in doing that, you give your secret to the program, and over the malicious dependency, they exfiltrate it to the remote location. And what's interesting, in most cases, malware is developed in a way that it runs at the moment when it's installed on your machine. In this case, they are laying dormant. If you install these packages, nothing will happen. So that's a way to bypass dynamic analysis, so defense solutions. So if you run this package on your machine, nothing will happen. But when you use its functionality, one of its functions, it will steal your sensitive data.
Right. So it's basically hibernating until you actually use it, in which case, right, the malware, the malicious functions.
In latest cases, it's functioning in pair. You have a package representing functionality you need and malicious package containing some suspicious functionality.
And once again, a crypto angle here,
Yes,
getting
very
access to
important.
crypto wallets, and right. Yeah.
Yes,
So
that's the team behind it.
Goes without saying, but man, if you're doing development work in relation to some kind of crypto platform or what have you, there are a lot of folks interested in that for the wrong reasons. Okay. Okay, and the final one, final package, invoke HTTP. So this was tell us a little bit about this.
Yeah,
I
this
think
campaign
Lucia
is still
or Carlo. Yeah.
That's what I said. In this case, new packages appear every 2 or 3 days. They contain pretty much the same functionality. What they do, they copy the entire requests package and its functionality and add their little malicious bit to it. What malicious bit does, it is base64 encoded string, which performs downloading of second stage from a GitHub repository. And that's, as I said, we have several accounts peering, constantly adding and removing malware from these repositories, and we've been reporting them. And why it's interesting, because it's impersonating the request package, which is a legitimate error popular target. Always, every month you will get a few packages trying to present themselves as variation of requests and trying to make people use them.
And we shared this image on social media, and this is the base64 encoded string within the file that was hiding the malicious code. Is that correct?
Yes.
So just as a heuristic, as an identifier, the presence of encrypted code should be something that you're sensitive to, or
large base64 encoded blobs are something that you need to look at. They are not always malicious, but in very much cases they are.
Yeah, they need to be there for a reason. If you can't identify, if you don't know exactly why they're there, that's something to be concerned about.
And again, try to use the legitimate requests package, not the impersonation one. So be aware of that.
So we're coming up on the end. First of all, if you got questions, use the Q&A feature. We'd be happy to answer them. One thing I wanted to talk about, or we want to talk about before we break, is of course, we mentioned it a few times, the secure.software, the Spectre Assure community. And this is a new, relatively newly released resource, really, for developers out there. Lucia, could you just tell the folks on the line just a little bit about secure.software and the Spectre Assure community?
So Spectre Assure community was published a couple of months ago, I think. It is completely free site. We have added previously on release date, we have added repositories such as NPM, PyPI, and Ruby gems. And a couple of weeks ago, we have added another repository, NuGet. And basically on this site, you can search any package that is on NPM, PyPI, Ruby gems, and NuGet. And you can see not only if they are goodware or if they are malware, but you can see their vulnerabilities. You can see some issues with them if they have. You can also see behaviors of those packages. So of course, if you're a developer, if you're trying to see if some package is malicious or not, you will search. But also if you want to see if they have some vulnerabilities, what is happening inside of that package, you can also search that package on the secure software site.
And we've
here
shown some of these screenshots. Yeah, I mean, this is what you would get, right?
Yes. Here, this package is actually from the research that Carlo talked about, the second research he talked about, the NuGet one. And here, obviously, it's a malicious package, but you can see if someone has been tampering with the package, some vulnerabilities, if there has been some secrets leaked in package, licenses. You can see also all versions of that package and what is happening. There are also behaviors of the package. Obviously, in this one, some behaviors are malicious as well, are connected to malicious behaviors, not necessarily malicious on its own. So yeah.
And to be clear, this is free for developers to use, correct?
This is completely free. This is completely free. You don't have to pay to use.
So a really valuable resource if you're out there, you've got some software you again are looking to understand a little bit more about whether it's legitimate, whether there might be red flags within the package itself that you need to be aware of before you implement it or install it. This is a resource that you can use.
Yes, and as you can see here, there are list of behaviors, what happens in the package, and if those combinations of behaviors look weird to you, then maybe the package, you can look at it a bit more.
Look at it closer, right? And that's often just that can be critical. The sort of, and we wrote about this with 3CX, Carlo, you did, about that desktop app package had some red flags in it that if you'd known about it either on the producer side or the customer side, might have given you pause before you push that out to your desktop. And that's increasingly as these attacks move.
Are available resource for determining the behavior of a package you're using, and if they are off what you expect from the package, take a double look or find another solution.
Yeah. Okay, we're almost out of time. So folks, if you've got a question, speak now or forever hold your peace, as the saying goes. And I would just, Carlo and Lucia, any kind of closing thoughts for the audience here? There's been a lot of really great, useful information.
Well, from my perspective, if you plan to use some package dependency from npm, PyPy, or the major repositories, go and try secure software. It's free, so you don't have anything to lose. Try to make yourself more secure.
Indeed. Final comment. We've got, if you enjoyed this conversation, we've got some other great ones coming up. The next one, October 16th at 12 p.m., 5 misconceptions of software supply chain security. And you can, there's a link in the chat where you can go register for that. We've got a couple that are, you can watch today on demand, doing more with your source. There's a great one with Joshua Knox and Jasmine Noel, two of our colleagues, on software supply chain 101. So if this is kind of new topic to you and you want to just get your arms around software supply chain risk, that's a good one to check out. And with that, I think we're done. Carlo and Lucia, thank you so much for coming on and speaking to us. I really appreciate it. It's always great talking to you, and thanks for the amazing work that you all do.
Thank you for having us.
Thank you, Paul.
We'll be back in Q4 with more research, and so stay tuned. Keep your eyes peeled, and we'll do our Q4 and end of year threat research roundup in a couple months.
Okay.
All right.
Bye.
Thanks, everybody.
Bye.